Looking at our aim for today. Today we're going to be using distribution and combining like terms to simplify expressions. So it's building on what we did yesterday. Yesterday we were combining like terms using the commutative property to simplify expressions. Today we're going to have that extra piece involved. We're going to be doing some distribution. So the first thing we're going to do is we're going to review some distribution. We're actually going to see some distributions that maybe you've never seen before. Okay? Today is going to be really focused in on details. I said yesterday was focused in on details. Today is going to be twice as bad. All right? So let's look at our first distribution. This one I think we can do all on our own. No big deal here. We have the multiplication on the outside. We distribute it to everything on the inside. 4 times x is 4x. 4 times 3 is 12. No big deal. Moving on to the next one. Also not much of a big deal. We're going to distribute the negative 2 in. Now, notice there are 3 things to distribute to. I have negative 2 times 2. That's negative 4x. I have negative 2 times 4. That's plus negative 8. And I have negative 2 times 2y. That's going to be negative 4y. Now, this isn't completely simplified yet because we know that we need to go through and clean this up. So we've got a couple of leaf chain switches to do here. So I can change switch that back to subtraction. Negative 4x minus 8. Change switch that minus 4y. All right, so this next one is where it starts to get really tricky. So, on problems like these, when we have a variable that we are distributing, there's going to be an extra step of work that I'm going to ask you to show. Looking at this one, there's also a couple other things that we need to do first. I see variables without coefficients. So I'm going to give those variables coefficients. This is not a negative, it's a negative 1. This is not a x, it's a 1x. Now, the extra step is that when you are distributing a variable, because this is not something that you are accustomed to, you are going to write out that distribution. So here we have negative 1x times 1x. This next one is negative 1x times 3. And this last distribution is negative 1x plus 2y. Sorry, negative 1x times 2y. Thank you. Now, here we have to figure out what's going on in these multiplications. I have a negative 1, an x, a 1, and an x. I can commute those however I want. So that's a lot like negative 1 times x times x. Negative 1 times 1 is?
1.
Negative 1 times positive 1 is?
-1.
Negative 1. X times x. How can I rewrite x times x? Monia? Not 2x. Psalm? X squared. That's like 2 times 2 we can write as 2 squared. So this is negative 1 x squared because we have an x times an x. For this next term, we have a negative 1 times an x times a 3. I can multiply the negative 1 times the 3 and I get negative 3x. And over here I have negative 1 times 2. That's negative 2. And I've got an x times a y. Can I rewrite x times y with an exponent? Because I can't do that, I just have to write it as xy. So here we're taking a lot of information that we've learned in the past. Exponents, distributions, good dates, bad dates, and we're putting it all together. All right, so what I need to do is I need to go ahead and switch any additions back. I also have this extra coefficient of 1 that I don't need, so this is negative x squared minus 3x, switch this back to subtraction, minus 2xy. There's a lot going on there. Okay? Over here, we're going to be doing the same thing. However, there's a couple things we need to do before we get started on this one. Jaime. Leave chain switch is definitely very important. There's also one other thing that I've said that we need to do when we're getting ready to simplify expressions. Jaime, go ahead and finish it up. Yep, so he's saying this 1x doesn't have a constant, so he's going to make it a 1x. Sorry, that's really sloppy. I'm going to try again here in a second. No, I'm not. All right. So here I'm going to distribute a negative 3x, and since I'm distributing a variable, I'm going to ask you, you have to write out this entire thing. This is negative 3x times 1x plus negative 3x times negative 3. So here I'm going to multiply the things that I can multiply. I can multiply the negative 3 times negative 1. That gives me a positive 3. And I can multiply the x times x, and that gives me x squared. Plus, I have a negative 3 and a negative 3 I can multiply together. That gives me a positive 9. And this x has nothing to multiply, so it's just 9x. All of my variables have coefficients, and there is no addition of negatives. Denzel, question.
Where'd you get the 3x squared from?
So that was from this first distribution where we had negative 3x times positive 1x. When we have something like this, we can multiply the coefficients here. 1 times negative 3. Sorry, that should have been a negative. I don't know how you guys let me get away with that, because that's definitely a bad date. And the x times the x, that's where the x squared comes from.
Wait, that's where like you say it from?
The x times the x, that's the x squared. Just like you could rewrite 2 times 2. That's the same thing as 2 squared. We can rewrite this x times x as if it is x squared.
Oh, okay.
Mr. LaRue. So the 9x is from this second distribution, the negative 3x times the negative 3. So I've written that distribution down here. And the negative 3 times the negative 3 gives me the 9. And the x has nothing to multiply with, so it just becomes 9x. Okay? Cassandra. I'm not sure I follow your question. I'm going to move on to some more examples, and perhaps it will clarify for you. Okay? So the next one is a little bit easier. It's still distributing a variable. So when I do that distribution, I'm going to write out the multiplications. 4x times negative 3x plus 4x times 4. (4x times negative 3x). I can multiply the number parts. 4 times negative 3. That's a bad date. Negative 12. And I see that I have an x times x, which would be an x squared. Plus 4x times 4. I can multiply the 4 times the 4, and that gives me 16x. That one's a little bit easier. All right, over here, again, I have a variable that I'm distributing, so we're going to write that step. I have 3x times y plus 3x times 3. 3x times y. I can't actually write that as anything more succinct than 3xy. So I'm going to have to leave it there because I can't combine different variables into one exponent. And I can't multiply 3 times x times y, any of that. The next one I add 3x times 3. So I have 3 times 3, that is 9 times the x, 9x. Here comes the super detailed one. The one that is the detail that everybody makes a mistake on. Everybody does it at some point. Either because they're not paying attention, Aurelia and Brandon, or because they just don't know what to do. So here's the deal. The first thing that you'll want to do when you see this problem is what? Solve. Leave, change, switch the subtraction. Now, we have to be very careful. We cannot leave, change, switch through that set of parentheses. We've talked about that before. So what happens is this negative sits outside this set of parentheses, as if it were a negative 1. And if there is a negative 1 sitting outside that set of parentheses, what do you think we need to do? Matthew?
I think you have to add 2 and negative 1. Then you get 1.
He wants to add 2 and do the negative 1. So if we're thinking about order of operations, that would be doing an addition before we have a multiplication. What do you think we need to do with that negative 1? Imani?
Multiply times 4x.
Right, we need to distribute it in. So I'm going to take this new negative 1 that was created after that leave, change, switch, and I'm going to distribute it in. Now what's happening with this 2 over here while I'm doing this distribution? Nothing, it's just hanging out. All right, so 2 plus negative 1 times 4x. So that's going to be a negative 4x plus a negative 1 times 2. Say negative 2. Alvin. Okay, where are you confused? Are you confused with the distribution or where the distribution came from? Okay, so let's go ahead and go back just a second and look at the way this problem originally was. I'm going to zoom in on it a little bit as well. So here I have this subtraction, and you want to leave, change, switch it. That's the right thing to do. However, we can't leave, change, switch through this set of parentheses. I can't just make this a negative 4x. That negative comes flying off, but it hits this parentheses and it gets stuck. So that negative that's sitting right outside is like a coefficient that's a negative, so we're going to put a 1 on it. Now that that -1 is sitting outside the front door, just like any of these other problems where we had something sitting out front the set of parentheses, we need to distribute it in. So I'm going to take this -1 and distribute it in. Is that more clear? Okay. So after this, if I want to simplify this expression, there's still some work to do. What do I need to do to finish simplifying this particular expression? Deidre. Add the -2 and the 2. So we're going to commute our like terms next to each other. And 2 plus -2 is?
0.
So using the additive inverse and the additive identity, this cancels out, leaving us with just -4x. That's much simpler than this original expression. Okay? And here we have one last example. Okay? This is a complex expression, but we can simplify it. So somebody with a raised hand, what do you think we need to do first? Alvin. Leave, change, switch. Okay. What do you think we need to do next, Tufa? Yeah, do the distribution. So I like how she said multiply because she's thinking about this as order of operations. This distribution is a multiplication, so it has to happen before we do any addition. So what's going to happen with this 3x and this plus 12 that are not part of this distribution? What happens with the 3x and the plus -12 that aren't part of this distribution? Denzel, what do you think?
I think you write it down there and put those two first.
Yeah. So he wants to commute them. We don't need to commute them, but we can just definitely bring them straight down. Here we can now do the distribution in the middle. 3x, or 3 times 4x, which is 12x. Plus 3 times -5 is -15. So now I'm really glad that I didn't commute them because I actually have my like terms already commuted next to each other. I got kind of lucky there. 3x plus 12x is 15x. -12 plus -15. That's like signs add. Take the sign of the larger number. And we have 15x plus -27. Kip yes or Kip no? Is this a final complete answer? Some of you saying yes, some of you saying no. What do you think we need to do? So we have one more thing we can simplify, which is how are we going to do it? Yep. So she's saying change switch it back to subtraction. And now we can see this expression is way easier to deal with than this original expression. Questions, Triana? This is a 3x plus a 12x. Remember that there's a difference between adding, that's combining like terms, and multiplying. Very good question and clarification. I actually want to go ahead and do a key point immediately because I think that it's really going to help us with our last problems. And the key point that I really want to do right now has to do with our steps to simplify. So I'm actually going to cross that 2 out, and we'll come back to the 2 in a second here. So our key points are going to be our steps here. Step number 1. What's the first thing that we've been doing in these problems? Joshua. Yeah, so we add coefficients that need to be added and leave change switch. So we're going to add coefficients of 1 and leave change switch. That's exactly like we did yesterday. Not a big deal. What's the next thing that we do? Denzel.
Add 1x to x.
So that's the adding the coefficients. Sorry, I didn't complete that statement. That's my fault. Add the coefficients of 1 and leave change switch. Sorry, Denzel, that was my fault. Yeah.
Does it have to be direct? It has to be directly in order, right?
Yep, I want the exact order that we did things in.
Okay. Look to see. No. Like, look to see what needs to be multiplied together.
Yeah.
And write it down.
So do the distributions. Find the distributions and do the distributions. Find distributions and distribute. Then what? So after we've done the distributions, what's the next thing that we've been doing? Joshua. Simplifying how?
If we have like the left block and then the left, just change it to a minus.
So you're a little bit further down the road because at this point, after we've done the distributions, we're oftentimes looking at something like this. What was the next thing that we did with this, Joshua?
When we did with that one was, we canceled out the others.
Monia, can you clarify? Yeah, we commuted like terms next to each other. Commute like terms. After we've commuted our like terms next to each other, then we go ahead and use the word combine the like terms. And then once we've got those like terms combined, then we can do the cleanup. Clean up coefficients. Clean up the coefficients. And leave change switch if necessary. Do that if necessary in there, because I know Denzel loves that in if necessary. I'm actually going to use if needed just because it fits better for me. In fact, he's so excited about the if necessary, it made his nose like just start running immediately. All right. So let's look over here at this first example here. I'm looking at this first example. What's the first thing that I need to do here? Brandon. Huh? Okay. Brandon, what's the first thing that you think we need to do here? Even before we do the distribution, there's one thing that we need to do. Looking at the list that we just created. Coefficients. And so I see one coefficient here that needs a 1 and another coefficient here that needs a 1. What else do we need to do, Brandon, before we can do those distributions? Leave change switch. Okay, so I'm going to now do my distributions. I'm going to show my distributions. Now notice in this problem, there are multiple distributions that we have to do. 2 times 1x, that is 2x. 2 times 3, that is 6. 4 times 1x, that is 4x. And 4 times negative 4, be very careful here. This is a bad date. It's negative 16. Now that I've got my distributions done, Denzel? Commute. So 2x plus 4x plus 6 plus negative 16. So I got my 2x, I got my 4x, I got my 6, I got my negative 16. Good. Didn't lose anything there. And now I can combine my like terms. And now I need to do my cleanup. I don't have any coefficients of 1, but I do have adding a negative, so I'm going to change switch that back to a subtraction. You've got to be super organized with your work. All right. I'm going to skip this example because we've done such a good job asking questions that I think that we're good there, and we need to save a little bit of time. And I'm going to move down to the last example. So here on this last example, what do we need to do before we do anything else? Caleb? We need a leaf change switch. That was for you, Cassandra. Yep. All right, so we're going to go ahead and distribute in now. Now with this distribution, I can see clearly in this first distribution that I am distributing a variable. What step did I say you have to write down if you're distributing a variable? Psalm, what do you think? Yeah, we're going to end up with some square terms, and in order to make sure that we remember to do that, we're actually going to write out the multiplication for the distribution. This is going to be 5y times negative 3y. And so at some point you'll become comfortable with this, enough with this, that you won't need to write out this distribution, but for the rest of this unit, until I feel comfortable that we're all comfortable, we need to write that out if we're distributing a variable. However, this distribution, we're not distributing a variable, we're distributing negative 7, so there's really no need here. Negative 7 times y is negative 7y. Oh yeah, we didn't put those coefficients there. Come on, Mr. Boots. Negative 7 times negative 7 times 1y squared is negative 7y squared. All right, so now we need to pay really careful attention and do these multiplications. I have 5y times 2. That's an easy one. Christopher. 10y. That was an easy one. That's like a regular distribution. This next one's the tricky one. I have 5y times negative 3y. Mr. Diaz. Perfect. He sees the negative 15 comes from the 5 times the negative 3, and he sees the y squared comes from the y times y. So in this distribution, we had the 5y times the negative 3y. 5 times negative 3 is negative 15. And y times y is y squared. Easy, right? Negative 7y plus negative 7y squared. Any questions about this so far? Denzel.
If you did the negative 5y times 2, isn't that... Oh, never mind.
Yep.
Because I wanted to do the 10y times negative 3y.
Yep, we can do that. All right. Triana. Shh, you should be tracking Triana. She might have a question that is pertinent to you as well. So Triana's talking about what's going to happen when we start combining like terms. So the first thing that we want to do before we combine those like terms is go ahead and commute them. So I'm going to take my negative 15y squared, commute it to the front. I'm going to take my negative 7y squared, commute it to the front. And then I'm going to take my 10y and my negative 7y. So now we're doing addition, Trayana. So when we're doing addition and combining like terms with addition, the variable always stays the same. So we have negative 15 plus negative 7 is like signs add, negative 22 y squared. Remember, when we're combining like terms, we're doing that addition, the variable always stays the same. Say that one more time. Right, perfect. Good clarification. 10y plus negative 7y. So 10 plus negative 7, that's opposite sign subtract. And we're going to take the sign of the larger number. And then we're going to look for any cleanup. I don't have any additions of negatives. I don't have any variables with coefficients of 1. So we're good. Jaime. Pardon? That was from this distribution, the 5y times the 2, the 10y, and then we commuted it over here. All right. I'm really happy with our key points as they are. So I would like to go ahead and have you move on to your together time.